So we are going to do all our sums for this function on the interval 0 to 2 using 4 sub-intervals. Now, first thing you're going to do is make a table. That's why I left all this space here, and then use your table to answer all the questions. As a side note, if your table's wrong, but all of your answers match your table, then I can give you credit for those. So like, no matter what, don't be a giver-upper. First, we need to figure out like how many numbers we need to put on our table. So from 0 to 2 is, 2 units. If you divide that into 4 sub-intervals, 2 divided by 4 would be 0.5, that would be a half. However, we can't count by halves. We're actually going to have to count by fourths. And why would I need to break it down even smaller than the halves? Like, which sum is like causing us to have to do that? Hold on, let me stop writing a second. Let's have a conversation about that because I think I lost everyone. Do you get that the interval's 2 units long? Okay, and you're dividing that into 4 pieces. 2 divided by 4 is a half. But I can't count by halves. I have to count by fourths because of the midpoint sum. You're going to need the one in the middle. If midpoint sum wasn't on here, you could just count by halves. But because there's a midpoint sum on there, you're going to need to count by fourths. So 1/4, 2/4, 3/4, this is 4/4, 5/4, 6/4, 7/4, and then 8/4 is 2. All right, now this is going to be the not super fun part. You have to take all those numbers and do what with them? Plug them in. We'll get through it together. You're going to be okay. Sometimes, do you remember that warm-up we did last week? Sometimes in the AP exam, they make you do ridiculous stuff without a calculator. So it's a good skill to have. 0, if you plug in 0, what are you going to get? 3. Good. That one's not bad. Here, do you want to do the easy ones first? Let's do 1. I like to do the easy stuff first and then feel like I've gotten started. If you plug in 1, you're going to have 16 plus 8 plus 3. Is that 27? And if you plug in 2, 2 squared is 4 times 16 would be 64. Plus, what is that? Plus 16 plus 3. So is that 83? All right, now let's go back and get the ones in between. It won't be as bad as you're thinking, okay? If you plug in a fourth squared, close, is 1/16 times 16 be 1. I'm just going to write these off to the side here. A fourth times 8. A fourth of 8 is 2. And then plus, they're all going to have plus 3 at the end. So that's, what is that, 6? All right, let's plug in a half. A half squared. A fourth of 16 is 4. Plus half of 8 is 4. And then again, they're all going to have plus 3 at the end. So what is that, 11? All right, let's do 3/4. 3/4 squared would be, you take 3/4 and square it. 9/16, that'd be 9/16 times 16 would just be 9. The 16ths are going to cancel. All right, plus 8 times 3/4. 8 times 3 is 24, divided by 4 is 6. And then they all have plus 3 at the end. What is that, 18? All right, 5/4. 5/4 squared would be 25/16. But what happens? Good, it would just be 25. The 16ths cancel. Plus, all right, 5/4 times 8. 8 times 5. 8 times 5 is 40. Very good. Divided by 4 is 10. And then plus 3. So 38. We're almost there. All right. 3/2 squared would be 9/4. Let me write that down. Let me just show you what it looks like. If you do 16 divided by 4, like a fourth of 16, you get 4 times 9, 36. Do you notice anything too about like what's going on here, like with numbers? Like Like, do you see how those are perfect squares? Like patterns, math, anyway. 3/2 times 8. 8 times 3 is 24 divided by 2. 24 divided by 2, guys, is 12 plus 3. 51. All right, one more. 7/4 squared would be 49/16. The 16s cancel, so oh my gosh, 49. All right, 8 times 7 would be 56 divided by, well, you know what, I don't want to do 56 divided by 4. Maybe divide by 4 first. 8 divided by 4 is 2. And then 2 times 7 is 14, and then plus 3. 66? That is 66, yeah.
Oh, I guess it right. Back to back.
Yeah, 66, I had to check. Okay, so what you want to do, there should be 4 sub-intervals, so go ahead and circle your sub-intervals. Don't be too proud to draw your circles. Okay, those are your 4 sub-intervals. And now I'm going to hit pause, and I want you to try and do the rest of the first page, and then we'll go over it together. You don't have to simplify any. In fact, do not simplify anything. If you do that, I'm going to have to set my answer key aside and stop what I'm doing and try and figure out if it's correct. Just don't simplify them, okay? All right, so what is the length of each sub-interval? Because they're all the same. 1/2. Okay, that's not going to change. Like, they're all a half. All right. So for the right Riemann sum, we're going to use the numbers on the right. That should be 11 plus 27 plus 51 plus 83. Cool? Okay. And then the left one would be 1/2, and then 3 plus 11 plus 27 plus 51. And then the one in the middle would be 1/2, and then 6 plus 18 plus 38 plus 66. And then trapezoidal. So there's a 1/2 in the formula, just like that's the formula for the area of a trapezoid. And then times the length of your subinterval, which just so happens to also be a 1/2. And then how do you write out your sum of numbers? The outside ones are just once, all the inside ones are twice because they're shared between the intervals. So it'll be 3 plus double 11, double 27, double 51, and then the 83 just once. Okay. Set up, but do not evaluate a definite integral to find the exact area under the curve. So it would be integral from where to where? What are your boundaries of your interval? Right, 0 to 2, and then it's the function. So 16x squared plus 8x plus 3. And then what goes at the end? Dx. Do you remember how we, that's it. Do you remember how we type them in the calculator? It's math 9. As foreshadowing the lesson for today, I'm going to show you how to evaluate that without the calculator. That's what we're learning today. Okay, so go ahead and flip over. These were your properties and your antiderivatives, so areas under the curve. So I'm going to pause again. I want you to try this side, and then we'll go over it together. All right, so I went and drew those graphs while you guys were working just to kind of move things along here. Number 6. We have integral from 2 to 7, and we have 2 to 12, and we're being asked about 7 to 12. I would write this out. Integral from 2 to 7 f of x dx plus integral from 7 to 12 f of x dx. You see what I'm doing there? From 2 to 7 plus 7 to 12 would give you from where to where? 2 to 12. And if you can do this without writing that out, that's fine. A right answer is a right answer. I don't need to see this if your answer is right, but you know, this is the property where that's coming from. All right, from 2 to 7, we were given that's -3. From 7 to 12 is what we're looking for. So I'm going to just call that x. That's like the missing one. And from 2 to 12 was 8. So -3 plus what gives you 8? 11 is your answer. Okay, or if you just were like, hey, Miss Cole, it's 8 plus 3, duh. Okay, well, fine, but that's the reason why you get the answer you got. All right, find the area under the graph of x plus 3. Slope is 1, up 1, over 1, and we start at 0, 3. So this is what that graph looks like. We want the area from 1 to 4. What shape did we get? a trapezoid and it's on its side. Okay, this is the height. So area formula for a trapezoid is 1/2 times the height. So what is the length of the interval basically is what we're looking at. This distance here is 3. And then what? Good. All right, so this one is 4 and then plus 7. Perfect. Did anyone simplify that? Probably don't. Okay. All right, here, absolute value of x. That's your V-shaped graph. We want the area from -2 to 6. You ended up with 2 triangles. How do you do the area of a triangle? Good. Base times height, 1/2 base times height. For this one, the base and the height are both 2. And then for the other one, the base and the height are both 6. Oh, that was a lousy 6. Let me fix that. Cool? Good so far? All right. Down here, you're given the graph. So let's do the area of this first triangle. 1/2 base times height. What is the base for that one? 8, good. Says the person that wasn't even here. And then the height is 3. Now I would actually work that out. 1/2 of 8, 4 times 3, 12. Now this is a semicircle. How would you do that area? We will need a radius in there. How do you do a whole circle? Pi r squared. So this would be 1/2 pi r squared. And the radius is 2. So 2 squared is 4, 1/2 of that is 2. Now it's actually -2 pi. Why is that? Below sea level. It's like a you want to think of it as accumulating area, and it is a de-accumulation. All right, once you have those, you just use them to answer the questions. Integral from -6 to +6. Well, that's the whole thing. So what would you put? 12 minus 2 pi. This is -6 to 6, but there's an absolute value. That means you treat all the areas like they're positive. So it would be 12 plus 2 pi. And then this one goes from 2 to -6. So you're going from here to here. You're going backwards. So -12. It's like an anti-12. Un-12. It is 12 backwards. All right, and then these are your anti-derivatives. What do you put at the end of every single one of these? Plus c. It's really important, all right? You need a function that this would be the derivative. It's like that's the answer you want the question. What's your anti-derivative of e to the x? Yeah, e to the x, fantastic. Minus, now cover up the 3. You add 1 to the power and divide by it. So it would be x to the 6th, and you'd have a 1/6 out front. You coming with me then? But it would actually be 3/6, which is 1/2. 1/2 x to the 6th plus c. You can always check these by doing the derivative. If you do the derivative of this, you should get what's there. All right, how about the next one? 4x, good, plus 1/3 x cubed plus c. This one we're going to rewrite before we do the problem. I'm not going to do the problem yet, so I'm going to leave the integral symbol and the dx in there. How would you rewrite 3 over x to the 4th? Yeah, and I'm going to bring the 3 out as well, but you guys are correct. X to the -4. If you want to leave the 3 in there, that's fine. That comes down to personal preference. But remember, you can never take a variable outside, only the coefficient. All right, so I'm going to cover this up. You're going to add 1 to the power. It makes it less negative. So it would be x to the -3. That means you would need a -1/3 out front. But -1/3 times 3 is just -1 plus c.